So let us continue talking about equity swaps, and basically we are now going to explore how to price and value three types of equity swaps. Number one, a swap to pay a fixed rate and receive the return on some equity. Number two, a swap to pay a floating rate and receive return on equity. And number three, a swap to pay return on one equity and receive the return on another. Typically, when we do equity swaps, the equity is an index. Does it have to be an index? No, it could be a stock, it could be any equity, but generally, equity swaps are based on some index. How many of you recall the basic equity swap from level 1? Okay, so I'll just give you a very simple example. So there are two parties, A and B. So party A and party B. In a simple equity swap, party A might pay a fixed rate, let's say based on, so for simplicity, we'll just say the rate is 5%. So you agree on a notional principal of say 100 million. And party A over, let's say, 2 years will pay a fixed rate of 5% payable every quarter. Okay, so how many periods will we have over here? We will have a total of 8 periods, and at the end of every period, party A will pay 5% of this. And if party B is paying based on an equity index, let's say party B is paying based on the S&P 500. So if the S&P 500 was 100 over here and it goes up to 120, then how much will party B pay? So it will pay 20% of the notional principal. This will be based on the quarter. Okay, so it's 20%, but then for the quarter it will be 1/4 of that. Okay, so that is actually 1 second. The equity, so the interest is obviously for the quarter. So 5% annual rate, that would mean 1.25%. But if on the index, is that, as in for the index it will be 20% because the index has gone up by 20% over this period. Right? So just a basic example, and this is what we did in level 1. So do you see that with an equity index, it's only with the equity swap, it's only at the end of every period that we know who pays whom what. Because it's only at the end of the period that we know the new value of the equity. But midway through this period, through the first quarter, if the equity index has gone up from 100 to say 115, then do we know that the fixed rate payer is winning? We know he's winning because he still needs to only pay on an annualized rate of 5%. But if he is receiving money based on the index and the index has gone up a lot, then clearly he is winning. Now, to figure out the amount by which he is winning, that's what valuation is all about. And you can see that clearly the value of that swap will depend on the price of the underlying equity index. So let's do example 6 from the curriculum. Consider an equity swap that calls for semi-annual payments for 1 year. The party will receive the return on the Dow Jones Industrial Average, which starts at 10,033.27. The current LIBOR structure is given right here. So the good thing about the curriculum examples are that they are all based on the same interest rate numbers, so we don't need to recalculate numbers. But still, for practice, we might do a little bit of recalculation. So let me just set this up. So this is what we are doing. We are saying that this is a 1 year swap with semi-annual payments. So the way this is set up at time 0, we have day 180, day 360. So at time 0, one party is going to pay a fixed rate based on these numbers. So the fixed rate we calculated before, and the other party will pay a return based on the index. Now, just to refresh our memory, if these are the two rates, so the 180-day LIBOR is 7.2%, the 380-day LIBOR is 8%. Do you recall how we come up with the fixed rate, the coupon payment or the C that we pay for every period? The C was 1 minus Z2 divided by Z1 plus Z2. And what's the Z1 and the Z2? These are the present value factors. So I'll do this very quickly. The Z1 is the present value factor for the first payment. Z2 is the present value factor for the second payment. So how do we come up with Z1? Z1, given that this is your 180-day period and the rate is 7.2, so Z1 is a present value factor. So this is simply 1 over 1 plus 0.072 over 2. Okay, because this is a half-year period, so you divide the annualized rate by 2. So similarly, you come up with Z2 and then use this formula and you will come up with C equal to 0.0392, that number that we have arrived at before. So given that the fixed rate payer is paying based on LIBOR, and given these rates, what is the fixed rate payer going to pay? It's actually already done. So he's going to pay this much every 6 months based on $1 notional principal, and then if the notional principal is exchanged at the end, that's $1 in this example. So this is actually a repeat of what we've done before. Now, actually, one more quick point. At this point, at time 0, do we know how much the equity payer will pay? We don't, because that will only be determined, the actual payment will be determined based on the equity value at each settlement date. All right. Now, 90 days later, the new term structure is given here. Interest rates have gone down. Okay, so what else do we know? We are told that the notional principal is 60 million. The way we'll do all our calculations based on $1 notional principal and then multiply our answer by 60 million at the end. The Dow Jones has gone down. Remember earlier it was 10,000 something. Now it's 9,955. So the Dow Jones has come down, and we need to figure out the value of the swap. So let's draw this out again. So this was time 0, 180, 360. We are now at this point. We are now at day 180. Interest rates have gone down. So anybody holding a bond or receiving payments is receiving fixed payments is happy, because interest rates going down, that means the present value of future payments has gone up. So what we need to do is figure out the value of the swap at this stage. Find the market value of the swap 90 days later if the new term structure is this. Okay, the Dow Jones is down. So now let's look at, so based on $1 and based on the fixed rate, do we know our coupon payments? So the fixed rate pair is paying how much? So what's the C value over here? 0.0392. And at this point, again, we have that same number plus $1 notional principal. So that's 1.0392. If you find the present value of these two numbers, given the current interest rates, what will you have? So if you are making a fixed rate payment, okay, then the present value of these payments is basically this discounted back over here, which is 0.0392 multiplied by a new Z1. How will you figure out this Z1 to discount this back? Yeah, so this discount factor is, I'll just calculate the Z1 for you. Z1 is going to be 1 over 1 plus, and then what's the new 90-day rate? 7.1%, so 0.0 0.071 multiplied by 90 over 360. So that's multiplied by 90 over 360. So that's the Z1 value, which is 0.9826 plus you have this value 1.0392. This is the payment over here multiplied by Z2. What will Z2 be? Z2 will be 1 over 1 plus, and what's the 270-day rate? It's 7.4%. 0.074 multiplied by what? Multiplied by 270 over 360. So 270 over 360, and that number is 0.9474. Okay, so if we do this entire calculation, what we will get is 1.023. Okay, so now this is the present. If this is the payment that needs to be made, a fixed payment, this is the present value of that payment, and since it's a payment, it's a negative number. So you can put this entire is a negative number because it's a payment. So $1 fixed payment based on these new interest rates, effectively we owe a little more, 1.023. Now, what about the equity side? On the equity side, we have gone down from 10,333 down to 9,955. So what you do there is 9,955.14 divided by 10,033.27. So imagine if you had put $1 in this index, okay, now that $1 would be down to this number, right? So it would be down to slightly less than 1. So the $1 in the index is down. The $1 that you put to receive these payments in the future, that has gone down to 1.023. You add these two, and what you will have is 0.0309 minus 0.0309. Now this is a loss of 3.09 based on $1 of notional principal. To figure this out for 60 million, you take this number, multiply it by 60 million, and what you will get is minus 854,000. Now the intuition, and this in the beginning might seem a little unintuitive, but if you spend some time on it, it will make sense. Okay, is the fixed rate pair losing out big time? If you were the fixed rate pair, what's happening? A, you need to make your fixed payment. Okay, so that fixed payment is reflected over here, and so you need to make your fixed payment, and what do you receive? You receive the return on equity. So what are you hoping for? You are hoping for the index to go up, in which case you will get hopefully more money than you need to pay. But what's happened to the equity? That's gone down. So that would explain the huge loss in value. Okay, now let's look at these items also. Okay, I mentioned do this for homework, but we'll just do it briefly over here. Recompute the market value under the assumption that the counterparty pays a floating rate instead of a fixed rate. Now, how will this work? So, if the counterparty is paying a floating rate, then what happens? How do you figure out the present value for the floating payment? And this again is a recap of what we've done before. So 0, 180, 360, we are now at 90. Okay, now the way you figure out the present value for $1, if this is a floating rate, do you have the new interest rates? The new interest rates are actually, I'll just write these again. The 90-day interest rate is 7.1 and the 270-day interest is 7.4. Now for a floating rate security, do we know the next coupon payment, the value over here? We know this payment. This was based on the interest rate that was in effect at the start. What was the interest rate in effect at the start? It was actually 7.2. Okay, so what would the C value be over here? It would be 0.072 divided by 2. Now what about the payment over here? We don't know. But what we do know is for all floating all floaters, the present value at the reset date will be what? Will be $1. So you take this number and discount it back using Z1. We calculated Z1 on the previous slide. So just like we calculated a minus 1.023 for our fixed rate, similarly we can calculate a number for this floating rate. So it won't be minus 1.023, it would be minus some other number. And to that we will add the same number for the equity. So the number for equity would again be 9955.14 divided by 10,033. 10,033.27. And this number over here, it's 1 plus this into the Z1, which I'll just write down for you. So this becomes 1.036 multiplied by 0.9826. Okay, so that is, so what I've just explained is one way of doing this. Another way, in case this seemed a little awkward to you, is imagine the following. So if you are, let's say, pay fixed, receive equity. Okay, so just at least once in your life do it this other way and make sure you get the same answer. So if the notional principal is given, then how do you figure out your pay fixed? You can look at the effective interest rate and see that for this period, how much did you lose out based on interest rate changing? And then that loss that you have, or that payment that you have, multiplied by the notional principal. And with the equity, again, look at what percentage you lost and multiply it by the notional principal. The answer that you get using this procedure should be the same as what we've done. If you understood what we've already done, then just go with that. Okay. The key really to understanding that stuff is at least do it once yourself. If you can just hear somebody explain it to you and then understand it fully, you are a genius. But if you are normal, then you need to go back and practice this. And if you have issues, let me know. Okay. Next, we'll talk about swaptions. So what is a swaption? Swaption is an option to enter a swap. And we'll see several reasons why this is useful. So again, an option to enter a swap in the future with a swap rate that is determined today. The terminology of a swaption is a lot like a FRA. So a 1/3 means the following. And let's say that typically with swaptions we express it in years. So a 1/3 swaption would be the following. You are sitting here at time 0. If this is time 1, this is time 3. You at time 0 know that after 1 year you want to enter into a swap. but you are uncertain. Let's say you want to be the fixed rate pair, but at time 0 you are uncertain about the fixed rate on swaps 1 year later. So what can you do? You can enter into a swaption at day 0. The swaption gives you the option to enter into a swap. Now, what's the benefit of a swaption? The benefit is that if interest rates go up, then you can exercise the swaption and get into the swap. But if interest rates go down, then you let the swaption expire out of the money, and then you just take a position given the current market rates. And we'll see an example of how this happens. But in my example, is the swaption expiring or ending at this point 1 or at point 3? It's expiring at point 1. The swaption is expiring at point 1. What's the underlying in this context? The underlying is a swap. Remember, what's the derivative? This is actually a derivative on a derivative. So what we are talking about is an option. So you are entering an option. It just so happens that with this option, the underlying isn't a stock, it's not a bond, it is sort of an interest rate, but more precisely, the underlying is a swap. And since this happens a lot, this particular instrument is given a fancy name that everybody remembers called a swaption. So remember, swaption is an option on a swap. Okay. Now, in general, when we talk about swaps and you think about the sort of terminology that's used, it is from the perspective of the fixed rate pair, okay, or the fixed rate. So, what's a pair swaption? A pair swaption, it doesn't say fixed rate over here, but wherever you see pair or receiver, it's the pair of the fixed rate. So, the pair swaption gives the right to enter a swap as a fixed rate pair, and a receiver swaption gives the right to enter as a fixed rate receiver. So if you enter as a pair swaption, you will benefit if rates rise. Why? Because as a fixed rate pair, if you enter into a swap where the exercise price is a 5% 3-year semi-annual pay swap, when this swaption expires, the actual rate is 6%. The market rate is 6% on the underlying swap. Have you benefited? You have benefited because you can now enter into a swap paying a rate of 5% rather than the market rate of 6%. So just remember this. If you have a pair swaption, you benefit if rates go up. And the opposite holds true if you a receiver swaption. So what are the uses of swaptions? Swaptions are used by parties who anticipate the need for a swap at a later date but would like to establish the fixed rate today while providing the flexibility to not engage in the swap later or engage in the swap at a more favorable rate in the market. So just to highlight the example that we were just talking about. So at time 0, if you enter into a 1/3 swaption over here and the exercise price is 5%, then you have the flexibility at this point to either enter into the swaption, or if interest rates have gone down to 3%, then you will not enter into the swaption, you will just use the market rate of 3%. Okay, so it gives you flexibility. Swaptions are used by parties entering into a swap to give the flexibility to terminate the swap. You memorize this in level 1 possibly if you were diligent. Now let's just make sure we understand this. Let's say you enter into a swap as a fixed rate pair, and then let me write this down. So you are a fixed rate pair. If you are a fixed rate pair, what does that mean? You receive floating. Now, let's say you entered as a fixed rate pair because your view was that the floating rate will go up. Let's say that the underlying floating is LIBOR. You might do this because you believe interest rates will go up. Okay. Now, if interest rates do go up, are you happy that you were the fixed rate pair? Yes. You are happy. But what if things go the other way? If things go the other way, then you will be kicking yourself, right? Because interest rates, like, what are the interest rates today? LIBOR is less than 1. If 2 years ago you had entered into a fixed pay at, say, 4%, you and your boss would be very unhappy with you. Okay. Now, if you had at the same time entered into a swaption that has the opposite position, you could exercise that swaption and effectively cancel out the current swap in which you already are. Okay, so I want you to think about this, and maybe you can just come up with some numbers. I don't think we need to go into details on this, but effectively this sort of a swaption gives you the option to get out of a mess. Okay. And finally, swaptions are used by parties to speculate on interest rates. So if you believe that interest rates will go up, then what sort of a swaption will you enter into? You will enter into a pair swaption, and as we will see shortly, you can make a fair amount of money if your position is correct.